So we're going to be talking about solving one-step inequality word problems. And it starts here by asking you to complete the table to identify words that might be used to describe different inequalities. So this table can be really helpful. We know that the different types of inequalities have different symbols. So we have this one, and this one, and this one, and this one. And so we're trying to figure out which of these words represent one of these symbols up here, right? So in the first one, it says less than, fewer than, smaller than, below. Well, it's not really difficult to figure out which one it should be because less than is the name of this symbol here. What makes this helpful is that they don't always come right out in the word problem and say less than. They may use one of these other phrases, but they also mean less than. So that's why this is helpful. And the next one, greater than, more than, larger than, or above. All of these can be represented by the symbol greater than. Okay, less than or equal to. Okay, can also be expressed as no more than. So no more than is kind of like the opposite of more than. So if it's not more than, what does it have to be? Less than or equal to. Okay, same thing with maximum. Maximum kind of sounds like greater. Okay, but actually the maximum is the most. All right, so it has to either be less than that or equal to that. Same thing with at most. That's the most it can be. Right, so anything else has to be less. Okay, and then greater than or equal to, that's going to be this symbol here. Okay, but it also will be expressed as no less than. That's like the opposite of less than, so that would be greater than or equal to. Minimum, okay, the minimum is the least, right? So it could be more, but not less. And then at least would be, it could be bigger than that, but not smaller. So if you have to make at least a 70 on your test, you can make a 70, or you can make larger than a 70, okay? All right, so we're just going to be writing in this first part the inequality for each of these conditions here. The first one says swim practice will be no less than 35 laps. So here you have the phrase no less than, and so if I look back up at my chart, I can see that no less than is going to use this symbol here, greater than or equal to. So it's greater than or equal to 35. And then what is it greater than or equal to? Well, it's practice, right? So this swim practice, so I can use P, it's going to be greater than or equal to 35 laps. So that means the minimum, they're going to swim at least 35 laps, but they might swim more, right? So this could be 36, 37, but it's not going to be 34. Right? Kevin ran for fewer than 5 miles. So here's your key phrase right there, fewer than. Means this one right here, less than, so that's the symbol, so it's going to be less than 5, okay, and then I can use K to represent what Kevin's going to do. So Kevin ran less than 5 miles, okay, meaning he could have run 4, 2, 0, something like that. Okay, the occupancy of the room must be at most 437 people, so this is our key phrase here, at most. Occupancy just means the number of people in a room. So at most 437 people is telling me that that's the most it can hold is 437 people. So at most is represented by less than or equal to, because if the most is 437, then you can't go over that. So this number over here has to be either less than that or exactly 437. So I can just use people, P for people. It's going to be less than 437 or exactly 437. And then number 4 says the temperature was above 38 degrees. So above is expressed with greater than. So above 38. And what is above 38? The temperature. So I'm going to use T for above 38. Now you could use a different letter for all of these. The variable doesn't really matter. It's just kind of holding the place in our inequality. But what is important is understanding the solutions that this is represented by. So if the temperature is above 38 degrees, then what I'm saying is temperature could be 39, it could be 40, it could be 400, okay? It can't be less than 38, and it can't be equal to 38. So I'm only using the greater than part here. All right, so now we're going to solve, and graph the inequality for each of the word problems. So Susanna's parents gave her $24 to spend at the carnival. If tickets for the carnival rides cost $3, find the maximum number of tickets Susanna can buy. All right, so what makes inequality word problems sometimes trickier than just regular word problems is that And they're kind of two different types of keywords you're looking for. One of the keywords you're looking for is the inequality. It's going to tell you what you're using. And then you might also be looking for an operation word. Okay, so an operation would be what the word's telling you to multiply or add or subtract or divide. And so sometimes they're obvious. Sometimes you just kind of have to understand from the problem what's happening and figure out what operation makes sense. So here I can see maximum. That's my inequality keyword. And I know maximum is represented by less than or equal to. All right, so, and I know that the maximum she can spend, right, has to be $24. So I know that whatever her maximum number of tickets can't put her over $24. So it could be less than 24, it could be exactly equal to 24, but it can't be any more than 24. All right, so how do we get to this 24? How is she spending her money? Well, she's buying tickets at the carnival, and each of them costs $3. So if I want to know how much she spent at the carnival, I would take the number of tickets times $3. So 3 times T has to be less than or equal to the $24 she has to spend. And if I solve this, I'm cutting it in half, isolating my variable by doing the inverse, all right? So this would be multiplying, so I'm going to divide to solve it, all right? And then I'm dividing by a positive number, so I don't need to change anything. So T is less than or equal to 8, right? If I want to graph that, then I'm going to start by putting a dot above the 8. It's going to be a closed circle because of the equal to part right here. And then where is less than? It's to the left, this direction here. And then if I just try to understand what this means, less than 8. Well, what is less than 8? So the maximum number of tickets she can buy is 8. So that means she could buy 1 ticket, 3, 4, 5, 6, 7, and she could buy 8, but she can't buy any more than 8 because after that she doesn't have enough money. So in my graph, I show that it could go on and on this direction, but really it would stop around 0, right? Because I'm not going to have -1 tickets. But I'm not going to change my graph. It's just something to understand based on the problem. Okay, and so another way I could write this is just to say, well, she can buy 8 tickets or less. Okay, just to show that I understand what T less than or equal to 8 means. All right, look at number 6. An elevator can hold 450 pounds if the passengers on the elevator currently have a combined weight of 320 pounds. No more than how many pounds can be put on the elevator? All right, so here I can see no more than is one of those phrases telling me the inequality that's going to be used here. So no more than, the no, that's kind of the important word there, is kind of the opposite of more than. So the opposite of more than is less than or equal to. And it's got to be no more than what? What's the maximum weight on an elevator? Well, it's the 450. All right, so I don't want to put any more weight than this on my elevator. All right, so how am I getting to this weight here? Well, I know that they already have 320 pounds, and anything else would be added to that. So 320 plus whatever more they put on there, so I'm going to use P for pounds, can't go over this 450 right here. All right, so if I want to solve this, I'm cutting it in half. I'm going to do the opposite, so subtracting 320. That leaves me with 130. So if I get ready to graph this, I'm going to put a closed circle because it's equal to, and then I'm going to draw my graph to the left and show that it's less than or equal to 130. And then again, if I'm trying to interpret what that means I can put 130 pounds on the elevator or less. Okay, I could put 1 more pound on the elevator. I could put 0 more pounds. Okay, it doesn't really make sense to say negative pounds. But 130 pounds or less on the elevator without exceeding the 450, which is the maximum the elevator can hold. Okay? All right, and then the last one says a bakery is preparing to ship an order of bagels. The baker can make 12 bagels every hour each. The order calls for 60 bagels. What is the minimum number of hours the baker will need to complete the order? So again, here's your keyword here, minimum. A minimum kind of sounds like less than, but remember that's one of those tricky ones. It's going to be greater than or equal to what? All right, so I'm looking for a minimum. So he could make more, okay, or he could make the exact order, which would be 60, right? He could have that much time to make 60. But he can't make any less than that, right? Otherwise, he doesn't complete the order. All right, so I don't want to be less than 60. I want to be greater than or equal to. All right, so the baker, how are we getting to the 60 bagels? So, well, he's making 12 bagels every hour, right? So 12 times the number of hours is how I'm getting the number of bagels he makes. Right, so if I go ahead and solve this, I'm going to cut it in half. The opposite of multiplying here is dividing, or the inverse would be dividing. So h, I divide it by a positive number so that I don't have to worry about changing in my inequality. 60 divided by 12 is 5. Right, if I graph this over here, it's going to be a closed circle above the 5. This time greater than is going this way. Okay, and then what am I saying? H is greater than or equal to 5. So the number of hours is either going to be 5, or it's going to be more than 5, okay, equal to 5 or more than 5. And what am I, so that means that the number of hours he needs to complete the order is 5 or more hours. All right, so it's going to, if he's only making 12 an hour, it's going to take him at least 5 to make 60, okay, or maybe more. Okay, so depending on what else he has to do, then the minimum number of hours is 5. If he had more hours, maybe he can make more bagels, but he needs at least 5 to complete the order. All right, so when you're solving one step inequality word problems, this is a great little table to keep handy, and it'll help you figure out which inequality to look for. And then, and then just always go back and sort of check to see if you've answered the question, if your answer makes sense. And so kind of interpret what the answer you got, see if it makes sense for the problem you were given. Okay, I'll see you in class.